Let's do our first case regarding assignment problems. Here we have 3 projects with the same priority, and management wants to assign project leaders to minimize the total number of days required to complete all 3 projects. Here are the project leaders 1, 2, and 3, and here we have 3 projects. We want to assign the project leaders to the projects in a way that the total number of days required to complete all 3 projects is minimized. For example, if we assign Terry to project 1, it would take 10 days. If we assign to him to client 2 or to the project 2, it will take 15 days, and to the project 3 it takes 9 days. Since we have 3 people and 3 projects, it's become a little bit confusing. Since the size of the problem is small, we can do it even with human intelligence, but we want to do it through a mathematical model. As we mentioned it before, a project leader is to be assigned to one client only. So for example, when you assign Terry, you want to assign Terry to any of these 3 projects, you can only assign him to one according to the logic that we discussed before. Here are the estimated project completion times in days unit for each possible project leader client assignment. The first step that we are going to do to solve this problem is drawing the diagram of the scenario we reviewed in the previous page, because as you remember, when we talked about this, that when you are dealing with network models, it would be very helpful if you draw the network first, and after that try to tackle all the problems similar to the previous problems that we had. So here, when you want to draw the diagram, you should consider some origin points and some destination points. Origin points could be the project leaders, and destination point could be the project. So, for example, if I consider such a thing, on the right we have projects, and on the left we have the project leaders. 1, 2, and it is just one type of graph that you can draw. You can do any other one, and I'm just doing one of them. Okay, what does it mean? If I connect 1 to 1, it means project leader 1 to the project 1. What does it mean? It means that you are assigning project leader 1 to project 1. Let's check how long does it take. If you assign 1 to 1, it would be 10 days. So I'm going to put 10. What happened if I assign 1 to 2? It would be 15 days. And like that, you can continue. Now, pause the video and try to draw your own graph. And after that, check it that how much more you are in control of the problem. Okay, you can continue this masterpiece with this type of connection, and you see it is completely a network. So you have the network, and you already have got for sure the ideas about this graph and just about the capacities. Project leader. How many project leader? Number 1. You have only 1. 2, only 1. Only 1. How many project number 1 you have? Only 1, only 1, only 1. And it is the simple part of the problem in comparison to the transportation problems or transshipment problems, because here you see all the numbers are 1. So your graph should be something like this. And it is very similar to the previous one, because all of them are network models. As you can see here, about the supply we have only 1, and about the demand we also have only 1. And here is the completion time in days, 10, 15, 9, and like that. So we have now a network model that we are going to tackle it exactly the same way we tackle transportation problems. So you see, my friends, the only difference between these models so far have been the initial step to understand the problem well. After that, the problem and everything is the same. Compare transshipment problems with transportation problem, and now compare assignment problem with the transportation problem. They are very similar, and we are gonna do the modeling very soon. Okay, here just we have a simple difference between the assignment problem and the, for example, transportation problem. Why? For transportation problem, the decision variables were something like this. For example, when we said x12, it was the units, the number of units transshipped, not transshipped, the number of units shipped from origin 1 to destination 2. It was the definition. Number of units shipped from 1 to 2. Okay, but here when we talk about, for example, y12, it wouldn't be the number of project manager 1 assigned to project 2, because it is only one project manager 1 and there is only one project 2. So it is in fact a matter of 0 or 1. 1 means assignment, 0 means non-assignment. So another simple aspect of assignment problem is their decision variables that can only take 2 values, 0 or 1. There is no other way here, my friends. For example, when we check this, let's check it together. We have Terry as the project leader 1. Can Terry be assigned to client 1? Yes or no? Finish. Terry to client 2? Yes or no? Terry to client 3? Yes or no? So the only thing that we have for the values we define here is 0 or 1, not any other value. So as you can see here, let's read it together. In 0, 1 integer problem, that is the problem that we just discussed. It is a problem that the decision variables can only take 2 values, 0, 1. In 0, 1 integer problems, each variable is represented only by 0, for example, no, or 1, for example, yes, and could represent selecting or rejecting an opinion, turning on or off electronic switches, or a straightforward yes or no answer used in various other applications. So it is just mentioning we have 2 states. So now regarding activity 2, it asks you how many decision variables do we have for this problem and what they are. Pause the video, take your time, and try to write the best answer that comes up to your mind. Here we have 9 decision variables. As you can see them here, x11, x12, x13. The project leader 1 assigned to project 1, project 2 and project 3. The same way for the project leader 2 and project leader 3. We have 9 decision variables, and here, for example, for x11, it is defined in this way. If x11 equal to 1, we interpret this as project leader 1, Terry, is assigned to client 1. And if it is 0, we interpret this as project leader 1, Terry, is not assigned to client 1. So you are supposed to write them in this way, my friends, because they are new types of decision variables that you are seeing for the first time. So you are gonna write them in this way. For example, for x11, it would be like this. x111, it would be 1 and 0. They are two values that it can take, and it is the case for every 0, 1 variables. So you put it like this. So you say x11 equal curly brackets, big one with 2 lines, and we have 1 and 0, and it would be here what you bring this description to here. If project leader 1 is assigned to client 1, and here again we have another one, and make sure you always, when you're defining decision variables regarding a 0, 1 variable, you should follow this protocol completely. We have x11 equal to 1, 0, and after that you put if. After the first if, you get if project leader 1, Terry, is assigned to client 1. And after that we have this one. So it says project leader 1, Terry, is not assigned to client 1. Let's do it for x, for example, 1, 3. 1, 3, I do it again. We have 1, we have 0. If project leader 1 is assigned to project 1. And after that, for the other line, we say it is 0 if project leader 1, that we get it from here, this one, is not assigned to project 1. And if we want to write it, my friends, in this general terms, if I ask you to write the decision variable integer value of ij, okay, if I'm asking you of xij, please pause the video and try to write it before you check the answer in the following slides. Okay, let's do xij. Xij, as we talked about it, it is a 0, 1 integer. So we have 1 and 0. It is 1 if project leader I is assigned to project J, because we have xij. So if project leader I is assigned to project J, and also we have this part that it says if project leader I is not assigned to project J. As you see, the decision variables regarding the assignment problem is very similar to the decision variables regarding the previous network models decision variables that we talked. Just the difference is that here we have 0, 1 variables, so there is a little bit difference between the definition. You need curly brackets, and you need to assign when each value is gotten.